right, here is your video on vector notes. So, a position vector. And vectors, they're going to follow along the same pattern as just position, velocity, acceleration, just regular old things, kind of very close to parametric equations. These vectors are going to have t's in them. So just like you had the parametric equations with the t's, very similar with vectors. So, position vector. Well, position vector is just x of t and y of t. So, like I said, parametric equations, you're going to have an x equation, you're going to have a y equation, they're both going to be in terms of t. To get the velocity, you do the exact same thing that you would do with a regular particle. You're just going to take the derivative. Now, notice I don't have parentheses. I've got these little v's on their sides. I like to call them vector brackets. That is not a mathematical term. It is something that I have coined. So, your little vector bracket here. X prime of t and y prime of t, so you're going to take the derivative of each one of them. Derivative of x will give you the velocity in the x, and derivative of y will give you the velocity vector in terms of y. Acceleration vector, that is going to be the second derivative in terms of t. Okay? All right, the next thing, the speed of a particle, or the magnitude, length of the velocity, is found by the equation. So you need to make sure that you're remembering they can ask for the speed or they can ask for the magnitude, which also could be the length. So lots of different words they could use when you're doing this formula. It's the square root of the dx dt squared plus dy dt squared. So basically, you're just taking a derivative of the x, squaring it, derivative of the y, squaring it, and adding those together underneath the radical. Okay? Now, the length of the arc of the curve from A to B, so the distance traveled of the particle from A to B, is another way that they could write the length of the arc. That is going to be the magnitude, but it's going to integrate from A to B. So the integration from A to B of that magnitude. So dx dt squared plus dy dt squared dt. So now you've got the speed, which is just this formula, and then the length of the arc is going to be that same formula with the integration from A to B. All right, so let's take a look at some examples here. We just have 3. Example 1, a particle moves in the xy plane so that at any time t, the position of the particle is given by these two equations right here. Find the velocity vector when t is equal to 2. So if this is the position, in order to get velocity, you've got to take the derivative. So I do my velocity with my vector brackets. The derivative of t cubed plus 4t squared is 3t squared plus 8t, and the derivative of your y is 4y cubed minus 3, how to get t? 4t cubed minus 3t squared. And we want to evaluate this when t is equal to 2. Now please use your calculator when you're doing that sort of thing. You're just plugging a 2 into both of these equations. I've already done it. We don't have to see me type those into my calculator. Your answer should be 2820. Now, the next one says find the acceleration vector when t is equal to 2. All right, well, the acceleration is yet another derivative. So we get 6t plus 8, and we get 12t squared minus 6t. We want to evaluate that at t equals 2 as well. So again, I'm plugging a 2 into my 2 equations, and I end up with 2036 with my little vector brackets. All right, example 2. Example 2 says a particle moves in the xy plane so that any time t is greater than or equal to 0, the position of the particle is given by, so position, here are our 2 equations. Find the magnitude of the vector, velocity vector, when t equals 1. So that means we're going to use this formula right here. Magnitude of the velocity vector is found by this equation right here. So you're going to do the square root of the derivative of x, so that's 2t plus 3, quantity squared, plus the derivative of your y equation, so that's 3t squared minus 6t. And you want to evaluate that at t equals 1. So you plug in a 1, you get the square root of 5 squared plus a negative 3 squared, which is 25 plus 9, with a square root of 34. Right? Again, use your calculator when you're plugging this stuff in. Not a big deal. All right, our last example, example 3. A particle moves in the xy plane, so that here is your position, x and y, where t is going to be between 0 and 2 pi. The path of the particle intersects the x-axis twice. Write an expression that represents the distance traveled by the particle between those two x-intercepts, and then it says don't evaluate. So if we're doing the distance traveled, that means that we're up here. We're doing the magnitude, but we're going to integrate from a to b. So we're going to have the integration of the square root of the derivative of square root of 3 minus 4 cosine t. Well, the derivative of square root of 3 is just 0. And then derivative of negative 4 cosine t is a positive 4 sine t. The derivative of 1 is 0. The derivative of negative 2 sine t is going to be negative 2 cosine t. That's a dt. So now we're going to figure out where we're going to go from top to bottom. So it says the path of this particle intersects the x-axis twice. Well, now think about the x-axis. Here's the x-axis right here. You don't know what the x value is going to be, but you do know that the y value is going to be equal to 0. The y value has to equal 0 in order for you to be on the x-axis. Well, here's your y equation. And you want to set it equal to 0 to find out where it will be on that y-axis. Sorry, the x-axis. 1 minus 2 sine t, you want to set that equal to 0. Well, subtract your 1, divide by negative 2, and sine is going to be equal to 1/2 at pi over 6, and at 5 pi over 6. So those are our two values, pi over 6 and 5 pi over 6. And it says do not evaluate, so you don't have to, although you certainly could. At this point, we would just put it in our calculator. Now, your homework. I know it says day 4 homework. That's just because I got it off of the College Board, and that was their day 4 homework. We're going to break it up into 2 different homework sets. So we're going to have 1 through 10, and then we're going to have 11 through 13. And I know that doesn't sound equal, but 11, 12, and 13 have multiple pieces to them. So there's actually 20 questions altogether. So we'll do half and half. So you are going to be responsible for 1 through 10. I will be doing a video on Tuesday that will go over it all. So I'm not just going to post the answers. We're actually going to have a video to go over them. So you do the work, practice them, and then once you're done, you can take a look at the video to make sure that you got them all right and you understand how you worked through them. And then we'll do the same with the second portion. After we go through the first portion, you'll then have a day to work on that second portion, and then I will post a video going over that second portion. And that will finish vectors. Vectors was a pretty small section. If we were using them for the AP test, we'd probably do more practice problems, but these 20 questions are going to cover pretty much what you need to know as far as vectors go. All right, great. Have a great 3-day weekend.